On their second moonwalk, Alan Shepard and Edgar Mitchell attempted to reach the rim of a nearby crater, but the lunar environment made the task impossible. Without an atmosphere to scatter light, they were surrounded by an absolute clarity that stripped away their sense of distance. They turned back just 20 meters from the edge, never realizing how close they actually came. During that disorienting trek, they grabbed a 9-kilogram rock nicknamed Big Bertha. It was brought back to Earth and sat unanalyzed in a laboratory for nearly 50 years, a silent witness to a discovery no one expected. In 2019, geologists examined a tiny fragment buried inside that rock and found something that shouldn't exist on the Moon, a mixture of quartz, feldspar, and zircon. While these minerals are common in terrestrial granite, they are virtually impossible to form in a lunar environment. Chemical analysis showed this fragment crystallized in a wet, oxygen-rich environment at a depth of roughly 20 kilometers. On the Moon, those conditions are non-existent. On Earth, they are entirely ordinary. This 4-billion-year-old rock is the oldest piece of Earth humanity has ever touched. It didn't survive on our planet. Instead, it was blasted into space by a colossal impact and preserved 238,000 miles away on an unchanging surface. Finding that rock on the Moon highlights a grim reality. There's not a single intact surface layer on our planet that reaches the 4-billion-year mark. Earth is a machine that actively destroys its own autobiography. Through plate tectonics, the ocean floor is continually swallowed and melted back into the mantle every 200 million years. The Moon, however, acts as a solar system archive. It lacks the atmosphere, water, and geological activity that erode or recycle our history. On its surface, a footprint can remain pristine for millions of years. Because our home planet relentlessly consumes its own past, reconstructing our history requires us to search for accidental records, extreme archives that manage to escape Earth's geological purge. The Eastern Sahara functions as a physical lid, concealing a lost ecosystem beneath its rocky expanse. What looks like a barren wasteland is actually a shield for the history buried beneath it. We can see through this shield using space-borne radar. If the sand is perfectly dry, long wavelength signals can punch 5 meters deep, bouncing off the solid geological structures hidden below the dunes. In 1981, this radar revealed a colossal network of vanished valleys and riverbeds. When scientists excavated these sites, they found stone tools and artifacts, proving that thriving human communities once lived across a green, fertile Sahara that was wiped out in a mere blink of geological time. We use a different kind of orbital vision in Antarctica. By flying 2 satellites in a tandem orbit and measuring microscopic distance changes, we essentially weigh the planet from space. Dense underground material exerts a stronger pull, tugging the leading satellite forward. This gravity map revealed a massive anomaly in Wilkes Land, a dense concentration of material 300 kilometers wide, buried beneath a mile of ice. This structure remains a mystery, a number on a gravity map that we have yet to verify. It is a sobering reminder. We possess more detailed maps of Mars's surface than we do of the bedrock beneath our own ice sheets. Our blindness extends even to the monuments we visit every day. We assume we understand these sites because they are visible, but the naked eye is a limited tool for archaeology. Physicists now use muon radiography to X-ray solid stone. Muons are cosmic particles that lose intensity as they pass through dense matter. By counting how many particles survive the trip through a pyramid, researchers can map out the hollow spaces inside. In 2017, this technique revealed a massive, previously unknown void inside the Great Pyramid of Giza. This space, at least 30 meters long, had remained hidden for 4,000 years inside the most heavily surveyed wonder of the ancient world. This same perceptual leap is happening at the Nazca Lines. While humans spent a century identifying about 400 figures, a machine learning model scanned the same aerial photography and discovered 303 new geoglyphs in just 6 months. These hidden patterns suggest that our historical blind spots stem from the physical limitations of our perception rather than simple erosion. We often fail to see what is right in front of us until we change the way we look. When the physical evidence is this sparse and fragmented, we face a different risk. In the absence of a complete archive, human imagination often rushes in to fill the silence. At Göbekli Tepe, researchers are currently debating the meaning of the vulture stone. Some argue that these animal carvings are an ancient astronomical calendar, recording a catastrophic meteor impact from 11,000 years ago. They suggest the figures represent constellations, turning the site into a massive prehistoric memorial. However, the archaeologists who actually excavated the site point out that these structures weren't built all at once. They argue that selecting specific animals to represent stars is a subjective process that can be manipulated to fit almost any desired timeline. This highlights the fragility of our understanding. When Earth's archive is broken, it creates a vacuum where data can be easily distorted to serve speculative stories rather than proven history. This struggle to preserve the past extends to human data, where the high cost of materials often led to the systematic deletion of older records. In the Middle Ages, scribes would scrape off old ink to reuse expensive parchment, creating a palimpsest. Using multispectral imaging, we can now see through these layers. In one prayer book, this technology revealed the lost star catalog of Hipparchus, a legendary work of ancient Greek astronomy that was thought to be gone forever. Because the Earth's axis wobbles in a predictable cycle, the positions of the stars change over time. By running this celestial clock backward until it matched the recovered coordinates, astronomers proved the catalog was written in 129 BCE. This breakthrough survived because of a lucky oversight. It endured not through a concerted effort to save it, but because a medieval scribe failed to scrape the parchment completely clean. Our intellectual heritage often survives by sheer accident. Because Earth is so hostile to its own history, we must look to the one place that keeps a permanent record. In 2013, researchers proposed a systematic search of the moon's surface for any anomalies left behind by civilizations that may have preceded us. The moon is the perfect repository. A chemical trace or an artifact left in the lunar dust could remain undisturbed for 1 billion years, while the same object on Earth would have been recycled by the ocean floor 5 times over. Critics correctly point out that finding nothing proves nothing, but the search represents a necessary shift in how we view our place in time. To uncover the true story of our civilization, we have to accept that Earth is designed to hide its secrets. To understand our own past, we may finally have to look into the void.